Bismillahirrahmanirrahim. How are you, students? Today we will study physics class first year, lecture number 35. Today topic is Doppler effect. Doppler effect. I am your teacher Aftab Alam. Doppler effect. The apparent change in pitch. The apparent change in pitch means frequency of the waves caused by the relative motion between source and the observer is called Doppler effect. Or you can write it also like this: the process, the change, the apparent change, which is due to the relative motion of either source or listener is called Doppler effect. If source and observer both are at rest, this is case 1, both are in state of rest, then V is equal to F lambda. F is equal to V by lambda and lambda is equal to V by F. Now we will discuss case 2. In case 2, if you look to case 2, when the observer is moving towards the stationary source, observer is moving stationary source, now let us consider that the source and observer both are at rest. Then velocity is equal to F lambda and F is equal to V by lambda. We already discussed this equation. Now the next is when observer is moving away, observer is moving towards the stationary source. Observer is moving towards the stationary source. When observer is moving towards the stationary source, change in wavelength is equal to distance traveled by the observer, distance traveled by the observer divided by number of waves. So del lambda is equal to VST divided by N is equal to Vs divided by N divided by T is equal to Vs divided by F. So del lambda is equal to Vs divided by F. This is the variation in wavelength. wavelength. Hence the apparent wavelength, which is lambda prime, will be equal to lambda minus del lambda v divided by f minus vs divided by f. Now next is frequency. Frequency is equal to v by lambda prime. So a prime is equal to v divided by v minus vs divided by lambda is equal to v lambda divided by v minus vs. So a prime is equal to this is f v divided by v minus vs into f. Now v minus vs, this vector, is less than v, so frequency a prime is greater than f, which means that when observer is moving towards the stationary observer, frequency increases. When the observer is moving towards the stationary source. Now the next case is when observer is moving away. Now when observer is moving away from the source, when the observer is moving away from the stationary source with speed v0, then the number of waves crossing the observer will be lambda double prime is equal to lambda minus del lambda minus v0 divided by lambda. Now taking v0 common, lambda is equal to v minus v0 divided by lambda. F double prime is equal to v by lambda prime. V is equal to, as we know that v is equal to f lambda, so f will be equal to v by lambda. Now I will clear the page. Now as we know that lambda double prime is equal to v minus v0 divided by lambda into t. The rate at which the observer is receiving the number of waves are f double prime is equal to lambda divided by t. This will be cancelled, and f double prime is equal to v minus v naught divided by lambda, which means that f double prime is equal to v minus v naught, putting the value of lambda v divided by f is equal to v minus v naught divided by v into f, which means that when the source is moving away, observer is moving away, the frequency increases. Case number 4. When source is moving towards the stationary observer. Change in wavelength is equal to distance travel, which is VST, distance travel divided by number of waves is equal to Vs divided by n divided by t. So del lambda is equal to Vs divided by f. This is frequency. Now, hence the apparent change in wavelength will be lambda minus del lambda v divided by f minus vs divided by f. Now, if double prime is equal to v divided by lambda double prime, putting the value of lambda prime, which is equal to this, so is equal to v into v minus vs into f, as v minus vs is less than v, so f double prime is greater than f. So when the source is moving towards the listener, the frequency increases. Source is moving away from the observer. Del lambda is equal to Vs divided by f. So lambda prime here is equal to lambda plus del lambda. Lambda is equal to v by f, and Vs del lambda is equal to Vs divided by f. This is the apparent change in wavelength. If double prime is equal to v divided by lambda prime, by putting the value of lambda prime, we will get that if double prime is equal to this, which means that when the source is moving away from the observer, the frequency decreases. Now, if you can see the given diagram, if waves is reflected from a source which is moving towards the observer, wavelength decreases. Wavelength decreases and frequency increases. This is the original wave when there is no relative motion. When the source is moving away, the wavelength increases. Frequency decreases. Doppler effect for light. A light wave's change in frequency is noticed as a change in color. If there is relative motion, there will be change in frequency which causes change in wavelength color. The Doppler effect will cause shift in frequency causing color shift. For example, object coming towards, it will appear blue. Object moving away will appear red. First, radio detection and ranging. Radar. Radio detection and ranging. A radar is used to determine the speed of an aeroplane. Radar is used to calculate the speed of an aeroplane. Speed of aeroplane. Speed of aeroplane. Speed of aeroplane by using Doppler effect. Using Doppler effect. Doppler effect. A radar is used to determine the speed of aeroplane and its elevation. The high frequency radio waves sent towards an aeroplane. The waves reflected from the aeroplane are detected by the receiver of the radar station. The difference in frequency is between incident and reflected wave is then used to find the speed of an aeroplane. The second use is sonar. Sound, navigation and ranging. Sonar. Sonar. Doppler effect is used in sonar. Sound, navigation and ranging. Sound, navigation and ranging. Sonar is used to determine the speed and depth of submarines and mines, etc. underwater. Speed and depth is calculated with the help of sonar. Sound waves generated are transmitted in water towards a submarine or any other object. The frequency of the reflected wave is measured and hence the speed of submarine is calculated. A bait bait a bait A bat uses ultrasonic waves to determine the nature and location of object from the reflected waves. Bat use ultrasonic waves. Similarly, an electromagnetic radiation sent by a source installed to a police car, the reflected wave from the moving automobile, which acts as a moving source, is received by the receiver, and Doppler shift in frequency of the reflected wave is then used to determine the speed of vehicle. So, speed camera fixed on the road. Use Doppler effect to calculate the speed of vehicle. Thank you, students. Allah Hafiz.